You are listening to a piece of the Salasin.10 podcast area.
So moving on from Singapore, we have Shang Yi, who is a software engineer from Harbour.Build, an Asia's leading technology company focused on construction industry. Let's lend our ears to Mr. Shang Yi, a Google developer expert in Firebase, who will be sharing his expertise on Firestore and Realtime database.
Hi everyone, thank you for your time coming here. So I'm Shang Yi, GDE in Firebase and also a software engineer at Harbour.Build. So I lead a team of mobile engineers that is based remotely. So I'm actually based in Kuala Lumpur. And we build construction super apps for the construction industry right now in Singapore. So today I will be talking about how you can actually build efficient web apps with Firestore and Realtime database. But a bit of a disclaimer, this title can be a bit of a clickbait. So the actual title here will be more on Firestore itself. And I hope that it will help you out. So before I do this, I would like to know how many of you, show of hands, how many of you have heard of Firebase before? Wow, that's great. That's a lot better than the one I did in Singapore. Yeah. So how many of you have actually used Firebase in your projects? Okay, keep your hands up if possible. How many of you have used Cloud Firestore? Then, okay, quite a few. Real-time database? Okay. So, besides those two products, anyone has any other products that they really like about Firebase? Shout out, anyone?
FCM.
FCM?
Yeah.
Authentication, hosting, cloud function. Okay,
Yeah, messaging.
awesome. I see a lot of great participation, so later on you guys will come down and get some Firebase pins I have. Yeah, so at the end of session, not now.
Yeah, they all
So let's do a quick recap of what Cloud
Only
Firestore is for those who are not familiar. So Cloud Firestore is a real-time database that sits on the cloud. In this case, specifically the Google Cloud Platform, right? So this allows you as a developer, regardless whether you're a mobile developer, a game dev, or even a web dev, to easily persist data across clients. So let's say you want to build the next new social media site or next new Twitter, you can consider using Cloud Firestore to get you quickly up to speed. So Cloud Firestore has been built with scale in mind, meaning it has written in a way that it will scale between one document to 100,000 or a few million documents across a few million devices. So Firestore has been created in order to give you that speed, that reliability that you most likely need when you grow bigger size in terms of your apps or even if your product. So it's a really cool feature to have in your apps itself. So it's like your default persistence layer if you're using Firebase. However, we do receive a lot of feedback about Firestore. So for those who have raised their hands that have used Firestore before, what is the number one concern you have about Firestore? Anyone? Price? I hear price. You?
Yeah.
Security rules, okay, we can talk about that later. Yeah, so I hear a lot of the comments here is about the cost, right? So I agree as well, which brings me to this, right? So when we use Firebase, the biggest reason why people choose Firebase at the start is always the easy barrier, the low barrier of entry, right? And at no cost, so you don't have to put your credit card at the no cost stage. But you want to use more of the features on Firebase, you have to go for the Blaze plan, which is free and you pay when you go. So one of the few things that we see in the pricing plan is they mention the word generous limits, right? And even if it says that it's a generous limit, we still hear concerns from customers about the pricing. So this is what I would typically imagine what developers would feel like when they're using Firestore, right? So Firestore is really fast, it's super cool, and there's a free tier, everyone wants to use it, but then there's this afraid of getting this cost coming into the picture when you grow, right? So it also typically becomes like this. People ask that Firebase is something that is really cool. Firestore, it's fast, it's reliable, you don't have to spend a lot of time getting it up, you don't have to spend resources tweaking it to go fast, and it's at the 99.999 SLA. So it's really reliable. But end of the day, people always come to cost, right? So this is a typical impression people have about Firestore. But let's see, is it really truly the case? So a common consideration you have as a dev that is working on Firestore is that although it works really well and you get things really fast out the door and data loads really quick, there is an inherent cost that comes with it and how this affects you, either as a business owner or as a freelance dev. Cost is always an important aspect when you're building apps, right? Because end of the day, everyone just wants to make money. So let's take a look at a typical example of how Firestore would look like. In a very simple page, let's say you project at least 10,000 active monthly visitors who visit your site, and let's say you are pulling 20 items from some of the database to display on your website. So let's say you're building an e-commerce site or some sort of site that needs to load data, right? So let's say just showing 20 items only, right? And you know users, right? Sometimes the internet can be a bit weird. Sometimes they don't think they're looking at the correct data. So let's put a more optimistic number of 5 reloads. So they just refresh the page 5 times. As well as, let's say, they use their app quite often. So maybe if you have 10,000 active users per month, it will cost you $2.10 for that single transaction. So do you think this is reasonable? Right? But end of the day, when we do development as engineers, right, we have to consider the scale of things that go further. A common feedback we get from people, from devs, is that when we scale, will it come back to bite us like you saw in the meme? How can we make sure that our apps costs stay low, at the same time serve a large scale of people? So as a dev, you have to consider all of this, especially when you want to grow in scale. And at the start, maybe that costing might not really affect you that much because it's just $2. But down the line, when you get really more users, it can slowly grow out of hand. So let's do a small trivia here. So let's say you are now asked to build this feature. There's this business case coming in that you want to show data that doesn't change often. Such as, for example, for e-commerce sites, you want to show the top 10 sales that happened in the week. So this can happen in an admin dashboard, it can happen in front of the customer side. But yeah, so these are 2 of the more common APIs that you get from the Firebase SDK, the Firestore SDK. First is to get docs, and one is on snapshot. Let's first take a look at what it means first. So get docs is kind of obvious, right? It's the ability for you to get documents out from the persisted store or Firestore here. And on snapshot itself is a listener to listen for data changes. So both these 2 APIs allow you to actually get data from Firestore. So after learning this, let's go back to the same question again. Which one do you think you should be using? How many of you say get docs? Okay, how many of you say on snapshot? Okay, so I see more people prefer get docs over on snapshot. So I personally also thought the same. So let's take a look at what it actually means from a costing perspective. This is the estimated document reads for the same scenario. In this case, I just switch between, just dumb it down the navigation between pages and page refresh for easy calculation. And the get docs itself costs 400K document reads. Let's take a look at on snapshot. Now on snapshot is half that number. You are down by 200K. So you would think get docs would be a better option because it typically means just to get the document, right? And it's straightforward, everything's done. But end of the day, when you look at the billing, this is how they're actually charged. So why does it happen this way? Let's take a look at what the SDK actually does. Is that when you use the get doc, it always fetches the latest data from the backend, no matter whether the data has changed or not. So in our case scenario, we wanted to get top 10 sales of the week. That doesn't change because per week, right? So within the week, it doesn't change, but the subsequent week it will change, right? So in this case, get docs will always fetch from the Firestore, and since you're always hitting the Firestore itself, you are charged with the number of document reads. But let's take a look at on snapshot. So what happens on snapshot is, first time when you load the page, you use the on snapshot handler to get data out, right? So when you get data out, the first thing, as always, it will always fetch the Firestore. But one of the key differences here is the on snapshot actually caches your data if the listener is still open. So meaning, let's say the person refreshes the page, navigates between pages, your listeners are still the same. And let's say you navigate between the other page and back to the main page, you are not actually getting the data again. It's always using the cached data. So this is what happens. So the reduction in reads actually come from the caching strategy that Firebase has to offer you. So this is something you can take a look at when you are using, if you're using Firestore and you're considering using Firestore as a way to reduce your billing reads. So this is one of the few strategies that you could use. Let's take a look at something that you would most likely see often every month on a specific date that is duplicated, right? So 1122334455 on all your shopping platforms. So let's say you want to do a flash sale, right? I want to display the top 20 items that are on sale today. So this list only changes once per day, right? It doesn't change on the same day itself. So what can you do? Let's take a look at how it will perform. In this case, let's also assume daily, because it's a flash sale, right? So let's assume that you have 10,000 users, right? And all the items on the page. So as usual, flash sale, right? People tend to refresh the page very often because they want to quickly get the deals or some sort of voucher, that expires immediately after you try to get it. So what people like to do is they always try to hit the refresh button, try to get the latest data. They don't know you're using Firestore, they don't know you're using its real-time capability, they just hit the refresh button. So this alone, let's just assume a 20-page refresh times, and that costs you 4 million reads, and that's a single day itself. So imagine a single week will cost you how much, right? So how can we actually solve this with on snapshot? With on snapshot alone, it still costs a lot of reads because people are hitting the main refresh button and the listeners are getting disconnected all the time. So you're hitting the refresh, it's hitting the back end again and pulling the data. So on snapshot itself does not actually solve this particular use case. So what you can do is that since the data does not change per day, why do we need to fetch it every single time the user refreshes? Why don't we cache it this time directly on the first time and just load it from the cache, since the data is always the same, right? So as earlier on, as we've seen from on snapshot, you can do the same thing. But what if you don't want to listen to real-time changes? You want to get just the data. So in this case, you can choose to use get, right, to get the data, and then you can actually use another function that is provided by the Firestore SDK is to get from cache. Is to allow you to subsequently fetch the same data from cache. So let's take a look at how it will look like in code. So this is running on the JavaScript SDK version 9. So the syntax might be slightly different, but should be okay. So in this case, in order to enable caching, you have to enable the IndexedDB persistent. It is not very well documented, but that's what you need to do in order to get this caching to work. So first, you try and get it from a cache, right? So since it's a first load, most of the time your cache will be empty because you'll never load the page in the first place. So if the page is empty, you can throw it out as an error, and then you can, after that, you can catch the error and only fetch it from the Firestore document. So you fetch the entire collection, and then subsequently when the person reloads the page, it does not need to fetch directly from the Firestore. All it has is from the cache itself. So this is a very simple implementation of how you can quickly reduce your number of reads. But this itself has an inherent problem. So before we go into that, let's take a look at what happens after this implementation. Since now, if you use the on-default on-snapshot handler, it gets disconnected every time you refresh the page. So with this approach, however, the cache is kept for you even though you refresh, because now, rather than relying on the event channel, we are now relying on the cache to serve the data for you. So now we can consider the page refreshes are, instead of 20, they are now into 1. So instead of the earlier 400K document reads, you're now down to just 200K. So you almost saved how many percent? I cannot count, so that's probably 90%, I would assume. So you can see how much savings you have done just by modifying the methods a little bit. So you might be wondering, why not just Firebase to ship these features directly in their SDK? Why do we need to write it ourselves? Could it be that they want to charge more? I don't know, maybe, but I don't want to be a conspiracy theorist here, but that could be something people be asking, that why is this not shipped directly by the SDK? Why do we have to do this ourselves? And there is a very good reason for it as well, because that itself has another problem. As usual, there's always more problems to fix. That's why we all still have jobs. But the problem here is that we're still querying from the server every time the user visits the page, even though the content is the same. So what you're doing, let's go back to the problem we had earlier on, is that we want to see the flash sale catalog that the user, when they hit the refresh button, they see, right? But since every single one of your users will see exactly the same flash sale items, it's an assumption, right? How can we make sure, it doesn't make sense for every single user to, it doesn't make sense to charge 10,000 document reads, for example, for every single user, right? If it's all the same, why don't we actually just cache it once and serve that cache content across multiple clients? So the earlier example was per client, you cache it per client. So the next time when they load, let's say on your phone, you will load it once, on your mobile, on your laptop, you load it once, then the cache will not persist across devices, right, obviously. So what can we do in order to actually solve this? Can we take this result, this snapshot data, and serve it across multiple users immediately? Since the data doesn't change, right, there's no reason why I should be charged 10 document reads, for example, per user, per time they refresh. Why don't I just get charged for 10 document reads instead for 100,000 users or even 1 million users? So this is what you can do to solve. So Firebase has actually introduced something called bundles, which has existed. It was quietly delivered last year. So how many of you have already know bundles? No? Great, then I still have a purpose here. So bundles are something new, or last year was added to Firebase, Firestore, that helps you with this problem. If you're going to send the same data repeatedly to all of your users, why do you want to charge every single user the same amount, right? So this is where bundles help. So what are they? So bundles are essentially just packaged results of common queries. So, for example, you are querying a result of 10,000 records, for example, or 10 records that is the same across groups. It could be this particular group of users will see this product catalog, that group will see another group, etc. And when you create a new bundle, you basically cache all the results somewhere. And this case is not in the machine not in the client machine, so it could not be on your phone, on your laptop. However, this data is stored somewhere else. And when your app loads and the SDK loads, you can specify to load directly from the query bundle. So you're not even hitting Firestore at all. And that saves you a lot of money by doing that. So let's take a look at how it actually works. So in order for you to start serving a new bundle, you first have to have a trusted environment to generate the bundle to begin with. So in this case, you could use your Node.js environment that you could have on your own, or you could already use Cloud Functions to help you with it. So the Firebase Server SDK here is the admin SDK that sits on the cloud storage, Cloud Functions. And your Server SDK will then fetch the data from Firestore. So your admin SDK will then fetch data as usually what you do on your client side. So you get the data you want. So in this case, I want to get the top 10 items on sale today, for example, and this will result in 10 document reads. And then what you do is that you use the SDK to add this bundle, this result bundle, to a specific query name. So in this case, I call it products. Or it could be top 10 products of 2020 or something like that. And that bundle can be saved somewhere. In this case, you can save it on cloud hosting, you can save it on your cloud storage or any of your persisted environment or your CDN if you want to. And then all your clients need to do is just fetch this bundle directly. So with this approach, you are actually not hitting Firestore at all. So this is what it will look like on the client side. I mean, correction, this is still the backend stuff. So it's the same thing, but more clear, I guess. And now your app can just fetch and read the bundle directly from a remote storage. So like I mentioned earlier on, it could be your hosting provider, it could be your CDN, it could be even cloud storage as well. Let's take a look at how you would write it in code. It sounds a bit complicated, right? But let's take a look at what you can do. So this is again in your cloud functions or your secure environment or your backend basically. And what you do is you just specify a bundle ID. And then you query Firestore as normal like you always do. Just query the data. But this, remember, this does not sit on the web app. This sits on your backend. And then you're just getting the query snapshot with all the data. And you just add it into a bundle name. In this case, I'm calling it latest products query. So now, once this bundle is created, you have to store it somewhere, right? So this is the part where your client will actually receive. So your client, you're going to fetch the bundle. So in this case, I'm just fetching it through an API because the bundle result is actually a large JSON. And that bundle itself, you just load the bundle into your Firestore SDK. So just load the bundle directly and just specify the query name you want. So the query we want is latest product query. And it's important to also specify the source. If you don't specify the source, but you still put the query in, it will still fetch from Firestore. So you have to make sure you add this in, and this should work. So after you've done this, you should see that your document reads from 400,000 or 4 million document reads, right, has now dropped to just 10,220. So the 10,000 here is from your daily visitors when they first open the page. And then the 20 document reads itself is from the backend that reads the documents itself. So you can see that if you're going to serve about 10K users, you're only costing 10,000 document reads. And the best part is this is within your free plan, your free tier. So with this kind of scale, you can imagine the amount of data that you're saving. So can I question from the crowd? So do you guys know where the 10,000 document reads come from? Can anyone take a guess where the 10,000 document reads come from? Anyone? Any attempt would find, I think I have a few Google Cloud, not Firebase marks lah, but they are Google Cloud, but it's the same thing anyway. Right, so gentlemen over there, do we have a mic that we can pass over to the crowd? So remember, before I answer, I just want to let you know that your clients are not hitting the database at all, the Firestore database, but where does the 10,000 document reads come from? The guy who raised your hand just now, the guy in white, right? Yeah.
I don't have an answer anymore.
You don't have an answer anymore? Okay, the guys at the back, the guy in blue jacket, yeah. Where does the 10,000 document reads come from?
From reading the data, the database, right, after they send the data in the offline storage, and then they read it once.
So I assume you're talking about
Yes, the remote storage. So they read once, so it will be 10,020. Is it?
this one, is it? You're talking about this section here?
Yes.
I'm sorry, that's wrong, but good attempt. Anyone else? The one just now, I think left hand side, yeah, the guy in white jacket. Behind you, yeah.
I think it's from the cache.
Good attempt, but no. But that brings a good question. You are still charged the egress of caching, meaning the bandwidth to download, they download the data, but that's not where the actual 10,000 comes from. Anyone? Behind?
Yeah.
Where? Oh.
The 10,000 comes from the number of daily visitors, and then 20 is from the number of products.
Good attempt, but no. So, so again, who was hint?
I bet you.
From the bundling, I guess, but I'm not sure.
Okay, I have to give it to him, right? That is the closest answer I get. So, it actually comes from the bundling, right? So what actually means is that what happens at the back is that Firebase still tries to charge you for getting this data out from the bundling itself. The bundling itself will get 20 items, right? But you are still getting charged. Hold on now. You might have confused me for a while. I might have confused this with something else, so you probably have to undo the clap, but let me think for a while. 10,000 daily active users trying to access the page, only fetching it once. I think this slide might be wrong. So sorry for bamboozling you guys. You can just come over and take a pin, I guess. Yeah, but that was not the correct thing I was trying to say, but it will come again. Don't worry, there's one more chance. So, sorry about that. Going back, you still save. I'm expecting to be at least 20 documents reads, optimistically 20 document reads, but I feel like there's somewhere I'm missing that I still need to figure out. But basically, you save a lot of reads compared to the previous approach that you've done. Okay, so let's take a look at another problem that you might have is that now we have solved a lot of the problems of fetching a lot of data, right? They are saving a lot of cost. However, now you have another problem as usual. Let's say now you're not doing 20 documents. 20 documents is meh, let's say. Let's say you want to do a few million records. You want to fetch a few million records down. Maybe there are data points on the dashboard you want to display, and 10 records doesn't do it. Maybe it's 1 million data points. And it makes a lot of sense to use bundling to fetch this data. For example, you want to do a report, right? A report of the statistics of an entire month, right? So you're using historical data that doesn't change. So in this case, let's say you need to get 1 million data points out from Firestore. It doesn't make sense to charge 1 million document reads for a single user, right? I'm sure there's more than one user to use this. So with just now the other way, with using bundles, we managed to save 1 million document reads because we're just hitting it once and serving it across all. But now imagine fetching 1 million JSON objects from the backend. You can imagine how large it will be. You can employ some sort of streaming methodology to stream the data down. It's up to you. But end of the day, we are loading this 1 million documents directly on the client side in order to display. So that alone can incur performance issues. In this case, it's really slow when you want to search data, for example. Because remember, in Firestore, let's say you write a query to search for data, everything is done on the back end. So what happens is that every time you create a new document with 10 fields, 10 indexes are created for you on the back end. So that allows you to perform very fast searching that you can do. It's almost O1. It's almost O1. So meaning you have 10 million records, one query just scans through the index to look for the particular index and you get the data alone. But this doesn't actually exist on the client side because the client side now needs to know how to search data. It doesn't know how to search. You could probably fetch the data and then you can use maybe .find or .filter on your JavaScript code to look for the data, but that will incur an ON, right? So what you can do is that you can use client-side indexing. So that sounds like a painful thing to do just to save money, right? As devs, we like to go to the fastest solution first. And what Firebase wants to do is to get you there fast. Their motto has always been to get you there fast. So let's take a look how you can implement client-side indexing to speed up. So before we go into that, let's talk a bit about how indexing, let's visualize a bit of how indexing look like. So for those who are not familiar, all your data are recorded in this particular map, and the keys here could be a category. So let's say I want to search data by category. So imagine you have a dashboard, you want to switch between a category of products that you want, like sales for for hardware, sales for baby products, etc. Right? So what happens on the back end is that you need to create an index, that is done automatically by Firestore, and items are categorized by your indexes. So here we are categorizing it by category, and each of these category will have a single document ID. So let's say you have 10 million records, you have 10 million indexes here. So since we now serve the data from the local cache in your devices, on your phone or in your laptop, right? You don't have this caching implemented for you. So what you need to do is very simple, actually. Unfortunately, I did not include this slide. But all you need is just what you need to do is just to export the index definition from Firestore and just load the index directly into it. So that should actually help you reduce the time to fetch, time to scan through data or time to query your cache data. So a common question we get from developers is that if bundling is so great, why is not everyone just using it? So there are a few key points that you should consider before you decide to bundle or not. Of course, cost is the biggest factor, but there are also other important considerations to take note. So bundling makes sense if you're going to read data that doesn't change often. In this case, it could be even configuration data, or it could be data, like I mentioned, a week of data that doesn't change, or month, or even, let's say, half a day, for example. So data that doesn't change often across multiple users, it makes a lot of sense to just use bundles. And also, it's also useful if you want to display data that's not personalized to the user. Let's say the landing page of a website, you want to display maybe your top 10 offers. Let's say you're building a WordPress-ish website, and you want to display a top 10 authors who contributed to your blogs or something like that. And all this standing data that does not require an authentication, it's something you should consider adding into bundles. And the reason why is on the next slide here, is that since these bundles now live in your storage, can live in any remote storage, so it could be your CDN, it could be a hosting provider, all of this data is not protected by any sort of authentication because they are now considered static data that is loaded. So if you have important sensitive information like your personal client details, right, then you should not be using bundles in this case because that data could be leaked out by someone just crawling through and looking for the bundles you have. And these bundles are not encrypted. So that is why that is something you should consider when you're using bundles. And it also doesn't make sense to change, to call it, to use bundles if data always changes, right? If my data always changes, for example, let's say a chat message that you're building, or let's say every few minutes there are new entries coming in, right? It doesn't make sense to use bundles because now your backend is almost performing the same number of reads to query the latest data and create a bundle, which in the long run will cost you more than just querying it directly from the SDK, from the cloud storage. Sorry, I mean the Firestore. However, if you're planning to use cloud hosting storage, right? Sorry, storage, cloud storage, you can leverage on cloud storage's security rules to actually help you out. because cloud storage has a security rule layer that can allow you to authenticate a user, and you can use that way to reduce the number of, to reduce the vector attacks against reading reading this sort of sensitive data if you choose to do it so. So let's also take a look at some alternative solutions to bundles. So let's say you don't want to do bundles. Let's say right now you deploy a really cool app and you really get a lot of users, and you can see your usage is skyrocketing, your sales is skyrocketing, but also your cost is skyrocketing, for example. So what can you do immediately? Let's say you need to issue a priority 1 fix immediately to production. If you don't have a lot of time to quickly test your bundles, right? Because time is ticking and every single day, every single time is money, right? So this is something you could consider as well, is to use real-time database itself. Although real-time database sounds like a database for you to store real-time data, you can use it for a lot of other things as well, because it's just a large JSON tree. So instead of writing bundles, you can actually potentially store all your data, those data that doesn't change on real-time database. And a bonus feature is that you have security rules to protect it against unauthorized reads, right? So you could consider real-time database as a faster way to get things done. So let's take a look at how it will work. So imagine you have an app that needs to get this of data. For example, you want to get things that you added to a cart. So you're an e-commerce site and you have things you added to a cart, right? So things in a cart, of course, it makes sense to store in Firestore, right? And there's no bundling here because you can always add and remove items in your shopping cart, right? So this data always change, so it doesn't make sense to be in a bundle. However, promotions that happen, it could be a daily promotion, a weekly promotion, a monthly promotion, for example, is data that doesn't change often. So here you can choose to either use bundles, or if you don't really have time, you can use real-time database and just use the on-value API on the real-time database SDK to help you out. So that will instead transfer the cost from number of document reads to now a bandwidth thing. And I can tell you the bandwidth cost for real-time database is dirt cheap, and you most probably don't see the significance of it. So this is an alternative solution that you could try out as well. The other issue we always hear from Firebase developers is, Firestore developers, is that how can I determine a size of a collection? So in this case, for example, you have 10,000 records, or let's say you're building a social media site, right? I want to see how many likes or how many comments a person has posted on your post, for example. And this is a problem that Firestore developers have faced for quite some time, but this is not a problem for SQL developers. So this problem itself, just a show of hands, how many of you know how to solve this without Firestore? Let's say your normal SQL. Anyone? Huh? No one. If I ask you to give me the total number of rows in the table, would you know how to write the query? Right? Right? Very simple, right? Select count from table, right? And then you're done. You get a total count. But although this sounds very simple, this does not exist for Firestore developers. And there's a reason why it's not. Because everything in Firestore is saved as a really large NoSQL database. So everything inside, you cannot use SQL to fetch it out. So what happens then? So what devs actually try to do is they do something like this. They get the documents they want, in this case comments, and then you dot size, or dot length, or whatever you have in your IntelliSense that give you. But this in turn will give you the total document count. So let's say you have 10,000 records and you dot size to get the correct number. It's easy, right? I mean, this should work. So although this will work, it actually costs you this. Let me go back. This is the amount it will cost you just to do the dot size. So let's assume you have 100 comments on one single post and you just want to see the counter for every single client. What happens now is that you get 1 million document reads because 10,000 visitors are accessing the same post. So this doesn't make sense, right? Why am I getting charged this amount? So I'm excited to share that Firestore has a new, we go to the next one. before I share the exciting news, this is what some other devs has tried to work around the problem, right? Instead of using size, some devs do a counter. So what happens here is that instead of fetching the entire collection from the back from Firestore and reading it through the total size, what it does is that they create a cloud function, a trigger attaching it to it, a Firestore trigger, and this trigger will execute every time a user has added a new comment. So let's say a person adds a new comment, and then in your cloud functions, it will trigger, and it will increase the counter by 1. So basically what's happening right now is that you have a cloud functions that helps you keep count. So one person adds a new document, you keep count 1, 2, 3, 4, 5, and then at the end of the day, when your app tries to fetch this data, all it needs to do is just get the comments document that has the total count. So in this case, you're only incurring 1 document read per user. So this is some of the other approaches that other devs are trying to work around the problem by keeping track of the counter themselves. However, I'm excited to share with you a new way of doing things. So the previous way, it will cost you this amount of document reads, but now we have a document write cost incurred to it, right? So Firebase has introduced a new feature called aggregate queries. Now, this sounds a bit familiar for the SQL guys out there, those who have the average, your sum, your count. But now Firestore has introduced their first aggregate queries, which is also called the count. I know it's not very original, right? But it's called get count from server, in case they are not specific enough. They are afraid you're confused, so now it's called get count from server. So what you do instead of getting the entire collection and dot size or iterating through, you can just issue a get count from server and you put in your query. So it could be your own Firestore query, but you just put in a query, it will give you the exact number of documents in the table. So let's take a look at how it will look like in code. And that's it actually. You just get the collection, in this case the likes, just call the get count from server, and that's it. You have all your counts given to you from Firestore. So it's a lot simpler compared to doing your counting by yourself and using the size, which will cost you a lot, and that's it. So let's take a look at the cost itself. So the cost itself is just 10,000 document reads. Because let's say you have 10,000 documents, no, you have 100,000 document reads, right, originally. But the way the counter works is that they don't actually charge you by the amount of documents you have, but actually per 1,000 indexes. So in this case, it only costs you 10,000 document reads. So you can see a change in the costing compared to previous behavior. So this is something useful that you should try out if you're already doing counting yourself. Yeah, try this new feature out. I can assure you will see a large drop in billing reads on your site. So let's go through a bit of the summary here. So as a dev, you need to understand how these SDKs work. How does the APIs of GetDot and OnSnapshot work? Depending on your use case, you might choose one of the other. I wouldn't say both of them, I wouldn't say OnSnapshot is always superior than GetDocuments. So it depends on your own use cases to figure it out and your own metrics, right? Consider using bundles to save your billing rates, right? Take advantage of the caching provided to you by the Firestore SDK and use client-side indexing to actually help you speed up your querying. And if you don't want to do all of that, you can consider using Realtime database as an alternate solution to bundle. And if you need to do counting, just feel free to use the aggregate queries instead to actually help you out. So with that all in mind, thank you so much. Yeah, this is my teacher. Is there any questions? So I'd like to ask anyone has any questions. I have 3 marks to give out.
Hello. If my Firestore mostly contain user-specific documents, is it still wise to use bundle? Like I just store everything in the bundle and maybe use client index or something to filter the data, or they just use on snapshot?
Okay, that's a very common use case. In this case, I don't recommend you to use bundle in the way you mentioned, because what happens then is that now your bundles will contain every single user information and everyone will be downloading the same bundle. So now everyone sees everyone's data. So I wouldn't recommend to go that way. However, if let's say you feel like you have a lot of personal information of the user, so let's say you have a few collections everywhere that's scattered around that contain specific details of the user, I would suggest you could use bundles to keep them, but you have to secure them in cloud storage. So you, instead of saving this into a public accessible bucket, you should be saving it in cloud storage and making sure there is also one more of the security rules to protect against it, so that only that specific user who logged in can see the bundle. So I would also add maybe a user ID to the bundle, to the query name, so that you know which query to fetch directly. And yeah, that is something you could try out. Yeah.
Okay, sorry, another question. So you mentioned about the aggregate query. Is that thing available in the old syntax? Because I really don't like the new syntax.
Yeah, okay, interesting. I will bring your feedback to Firebase team to say. So just before we go into that, do you know why they decide to move to the new syntax? Anyone know why? Why did they want to make your life a bit more difficult, right? It's because what they wanted to do was to actually reduce your client-side bundles. So the new V9 SDK is actually tree shakeable, meaning your bundler will immediately remove methods that Firebase that you don't use from Firebase, and now you have a smaller bundle size. That's why now you will see exports of all the Firebase functions. So it's a more of a trade-off thing. Some devs prefer the namespace way, where you have Firebase.get or something, Firestore.get and stuff. But that is making it not tree shakeable, because all of these functions are now tied to the Firebase namespace. So it's like a trade-off between user experience and performance. And in this case, unfortunately, performance wins. But going back to your question, yes, it's available in the V9 namespace, V9 SDK as well. But they recommend you to migrate to V9. The reason why it's still there is because of people who also feel like V9 looks better than, V8 looks better than V9. So that's why they have to also include those features in. So you can continue using your V8 SDK to use these features.
Okay, thank you.
Anyone else? The one behind? I still have more marks though, it's just there, so I'll bring them out later.
Hi Shangi, so I'd love to ask about caching, right?
Okay.
So you mentioned that the gentleman over there, he wanted to cache user-related documents using bundles, but you said the bundles has to be shared with the clients, and each user would then be able to access every other user's data, right?
Yep.
So is there a way that we could do caching on the server side instead on the client side?
So that's a good point. So caching, so when you cache it on, let's say your CDN or cloud storage, right? There is technically already a caching layer on the server side. However, you can tweak this caching if you want. So let's talk about cloud storage itself. So you want to do that, you can. So what you can do is that I would recommend you to, instead of bundling every single user's information, you are just bundling that single user. So you will have, let's say your system has 10 users, and so you have 10 different bundles inside your cloud storage itself. And you can of course set the cache header in cloud storage, and you can say, let's say the max age you want to expire it after a month, for example, or a week. You just set it there, so what happens is, it just fetches directly from the edge, but it always goes through your security layer. So the more important point here is that you have to make sure that your bucket is not public domain. So if you're going to use cloud storage but not implement security rules, then it's a bit pointless. So you have to add security rules where, let's say, you are checking, this person is trying to access the bundles bucket of this user. Does this user belong to the same user who is trying to request for it. If it's no, then you reject automatically. So you can do that on the security rules for cloud storage. Yeah. Did I answer your question?
Yeah, definitely. Is that component available on GCP or Firebase offerings?
It's available on Firebase as well. So you can just go to the document section on cloud storage. Yeah, you can look at the setting the cache control for one, and also look at the security rules section as well.
Would I be charged for that, for using the cache?
No. Last I remember, you are only charged the bandwidth of downloading the bundles. So let's say your bundle is 1 meg for some reason, right? You are going to charge the amount of downloads you have done for that bundle itself. So even if you cache it, yes, it's still considered chargeable. Yeah. You want it to be free, right?
No, but I'd assume that would be much cheaper if you were to do queries every time.
Yes, definitely much cheaper. So I wouldn't say this is a magic bullet that solves all your costing problems. It is at least a step closer to reducing your billing rate so that you don't get too afraid to put your feed into Firestore. Yeah, I think we have a question from the front, right? And we have one more from the back as well.
Going back to the bundle question on the 10,000, 20 just now, right? Can we revisit the slide?
Okay, this one really want to win, okay. Joking. This is problem solver.
Yeah, that way also can actually.
I did this slide in the middle of the night, so I probably wasn't too
Can't be sure, you got to use the cost calculator.
Where did it go?
I think there is two scenarios here where this could be correct or another scenario to be correct. Based on your presentation on the aggregated theories, right? So every single read you get charged for one document read. So upon creating the bundle, will it be you charge 20 for the 20 top results per page? That will be 20 reads.
Yep.
Then subsequent daily visitor reads will be reading one bundle. That's why we get 10,000. Would that become that number of 10,020?
No.
Oh no.
No. Yeah.
Then
so
in another scenario, would it be 20 item reads counted as one read? So it would be 10,001 read?
20 items considered as one read? No, because in this scenario, the whole point of the bundles is to call it once for the entire session.
Yes, but you need to read it from Firestore first to create the bundle, right?
Yes, so the bundles, if let's say your bundles are created on demand, meaning when the person visits the site and then you start the bundle creation, then yes, you probably come to this figure. But in this case, you have this overhead of a lot of time taken to generate this bundle. So I wouldn't say it's a feasible, it wouldn't be a normal scenario of how someone will implement it. So typically they will have a cloud scheduler, run a batch that runs, let's say, every midnight, every time just to create this bundle. So I don't see where the 10,000 could come from. Yeah.
Then
But
for bundle size, right, is there a limit that we should pay attention to so when the client requests it, it's not too big that it kills the client side?
yes, that's a very good question. So I don't have an answer for you right now, but that's a consideration you have to take. So in case your bundles are too big, now you need to be considered, should you separate your bundles into smaller chunks, or whether should you even be serving this much data at first glance in the first place? Obviously now, since this data is served, since this data is just some raw data, you can choose to compress it if you want to. But it is a very important point to take note when you're creating your bundles, because now you have to consider time to load the bundles, download the bundles to your clients. Yeah, that's a good point.
Okay, thank you very much.
Thank you. I think the last question, you all clap already? Hey, got one last question. No more already. Okay, for those who want to ask questions, I'm always available. And those who ask questions, please take your stuff and pins whoever wants Firebase pins. Thank you.
So fast last session already.
Yep.
going for the other one, right? Or you going back?
I think this not
Are you going for this one standalone component optional?
standalone component.
I think I'm going for the ML one. Going on.
There's actually like one more session, right?
Yeah, this in this hall is standalone component with optional NG module.
Oh, Angular, yeah, no, I'm not going.
Oh, so which one?
That was a piece of the Salasin.10 podcasterium. It is hoped that you have enjoyed it. If you have any issues, please feel free to leave a comment through any of the channels.